Hello, welcome to ANS Solver. This is the fourth question of the paper. So as you can see here in the first part, I need to show that dy by dx is always negative. So as you can see, I need to use something called as the quotient rule here. Okay, because a variable is divided by another variable. So I basically take my u as 1 plus e raised to minus x, and I take my v as 1 minus e raised to minus x. So I take my u dash, which is a differentiation of 1 plus e raised to minus x, basically as e raised to minus x as it is, but multiplied by negative 1 because that's the differentiation of minus x. So now I basically get minus e raised to minus x. Now same with v dash, I get minus e raised to minus x multiplied by minus 1, which gives me e raised to minus x. So now I can use my formula, which is vu dash minus uv dash over v square, which I can simply write as minus e raised to minus x into 1 minus e raised to minus x minus uv dash, which is simply e raised to minus x into 1 plus e raised to minus x over v square, which is 1 minus e raised to minus x. So now I can take e raised to minus x inside the bracket. So I get minus e raised to minus x plus e raised to minus 2x. Okay, minus e raised to minus x minus e raised to minus 2x over, this is basically a minus b the whole square, which can be written as a square plus b square. Okay, minus 2 into a into b. So now I can write this basically as, I know this will get cancelled here. So I'll get minus 2 e raised to minus x over 1 plus e raised to minus 2x minus 2 e raised to minus x. So now I know this is my dy by dx. Now I need to prove that it's always negative. So basically here, if you notice, my numerator is negative and my denominator is positive, and negative over positive is always negative. That means my dy by dx is always less than 0, which means it's negative. Okay, yeah, so this is the first part. Now the second part, the gradient of the curve is equal to minus 1 when x is equal to a. So now I know my dy by dx is equal to minus 2 e raised to minus x over 1 plus e raised to minus 2x minus 2 e raised to minus x. So when my x is equal to a, I know my gradient is minus 1. So my dy by dx is minus 1 and I have this x as a. Okay, this is what I have. Now what I can simply do is, I can write this as minus 1 into 1 plus e raised to minus 2a minus 2 e raised to minus a equals to minus 2 e raised to minus a. So I can write this as minus 1 minus e raised to minus 2a plus 2 e raised to minus a, which is equal to minus 2 e raised to minus a. Okay, this is what I can write. Now what I can simply do is, I can write this as minus 1 minus 1 over e raised to 2a equals to minus 2 e raised to minus a minus 2 e raised to minus a. Correct? So now I can basically take the LCM here by doing cross. So I can write this as minus e raised to 2a minus 1 over e raised to 2a. So now I can write this as minus 4 into 1 over e raised to a. So now this can be written as minus e raised to 2a minus 1 equals to minus 4 over e raised to a into e raised to 2a. So now using simple indices, e raised to 2a over e raised to a is basically e raised to 2a minus a, which is e raised to a. So now I have minus e raised to 2a minus 1 equals to minus 4 into e raised to a. So now what I can simply do is I can write this as e raised to 2a minus 4 e raised to a plus 1 is equal to 0. This is what I needed to prove. Okay. Now I need to find the value of a. So if you see, I can say let e raised to a be u. So I have u square minus 4u plus 1 is equal to 0. Now I can solve this quadratic on the calc. So on the calc, what you can do is you can go to mode, then you can click on 5 where equation is written, then you can click on 3. Now when you click on 3, you get 3 coefficient boxes. So now in the first box, put the coefficient of u, which is u square, which is 1. Then in the second box, put minus 4. And in the last box, put 1. Okay, only the coefficient. So 1, minus 4 and 1. So now you'll see I'll get e raised to a basically, because I've taken e raised to a to be u as 2 plus root 3, okay, and e raised to a basically as 2 minus root 3. Now this won't be possible, so I'll only focus on this. So I can write this as ln e raised to a equals to ln 2 plus root 3. So now I can use the log property, which suggests that log of a raised to b is equal to b log a. Correct? So I can write this as a ln e is equal to ln 2 plus root 3. Now I know ln e is 1, so a is equal to ln 2 plus root 3, which is the exact number, okay, for a.